Hello, this is Alice Gentili from Miscoe Hill School. I'm here to tell you a little about our 3D printing journey at the Miscoe Hill School, thanks to a grant from MakerBot company of about $2,600 and a little bit of crowdsourcing from Donors Choose. We only had to raise a couple of $100. And for that, we received 4 spools of monofilament and a replicator too. That being done, we formed the Miscoe MakerCrew. This is a group of middle school kids who met after school once weekly to try to understand how to design and print with a 3D printer. And the rest is history. Or is it the future? We wrote thank you notes to MakerBot and to our donors. And one of the students designed a truck to give to one of our donors who owns a trucking company. Our first thing that we printed was a downloaded model from MakerBot's Thingiverse, which is the snowflake that you see here. You can see the bits of raft attached to the back, and that's what it looks like when it's all cleaned up. We experimented with different design apps and programs, including Blender, but they were very difficult for our kids. And we almost gave up, but then we found 123D Design by Autodesk, which was a lifesaver and helped us design right on iPads in our one-to-one school. It worked out beautifully. The kids were very comfortable with it, and we were able to download files and print them. This is the first design I did. The assignment was design something using only rectangles. And so this is what I came up with. It's actually a pendant, and those are just some 3D rectangles. This is the first printing of it. I used a translucent monofilament. I was hoping it would be a little more glittery, but that's okay. And then Andrew designed, his very first design to build was this truck, which he designed to give to our donor who owns a trucking company. He had to change it up a little bit around the tires, and he revised it, and it worked out great. There's Andrew with his iPad and the truck that he designed. Ben's first design to build is a little bit different and a little bit clever, and he enjoyed watching it build every step of the way. It took about an hour to build. He designed a 3D printer, which was very clever, but he was at the time enthralled with the process, and I wanted to make kind of a mini-me model of our printer. And here's Ben with his design printed. The next thing we embarked on is the castle project, which is still a work in progress. I'm designing a steam unit right now using these ideas in these projects. This is the one I came up with just as a troubleshooter to make sure it would be easy enough to do. What I love about 123D Design is that you can add color, and it looks really, in this case, it looks like a big old bouncy house or something, but by adding the color, you can make it look festive. The challenge is then, how do you do that when you have a solid white 3D printed castle? And here it is printing. The kids eventually, every student, every member of them, each designed a castle, and we printed them out. It takes between half an hour and 3 hours to print them, depending on the complexity. Here I am very proud at my first 3D printed castle, complete with turret. Here's Andrew's castle. I know we had a little problem with the raft on this, the stuff along the bottom there, because he had separate buildings, but still very proud to have been able to print out his castle. Owen's castle had kind of a ramp thing going on that he needed to revise and adjust. What was happening is the 3D printer didn't know where to start printing it in this one particular area, but Owen was able to revise that and change his design, and it worked out beautifully. It's a gorgeous castle. These are some slides to show you our process of uploading files and then downloading them again. The first thing we do is we design the models using the 123D Design app, and then we upload them to the cloud. We maintain a page, or we have an account with 123D Design online, and this is where we store our models. From there, we simply click on the model, and then we open up the file, and we're able to download the file as an STL file. And it's that we use to print out the piece. We save the STL file and then we open it up in MakerWare, which comes with the MakerBot. We open it up in the MakerWare software, which simulates our design board, and we can make sure that it's an appropriate size and that the shape is going to work and that there are no gaps between the model and the board that we're building on. Once that's done, we push the Make button and the file is sliced. And then the file is verified and it's ready for printing. We then save the file to an SD card that goes right into the MakerBot. Once we load the SD card in, it's simply a matter of choosing which model that's on there that we want to print, and then we tell it to print. It warms up and it starts to print. We keep the 3D printer in a corner of the art room with kind of a soft ribbon rope between it and the children. I've been experimenting with adding color to the models. I tried to use traditional model paints, but the smell of the enamel paint wasn't good, so I did try some acrylic paint. The acrylic paint works really well, and we're going to start using that at school. I was able to get a 3D digitizer scanner over the summer, and we're going to be experimenting with that in the classroom. The goal is to be able to make things out of other materials, scan them, and then be able to print them using the 3D printer. This fall, I'd like to get a group together to design some robots that can then be 3D printed in parts which snap together. I'm hoping to be able to do this after school in the fall as part of the enrichment program. As you can see, there's truly a wide open variety of things we can do with a 3D printer. From my perspective, it's primarily about design, the design process, design considerations, as well as editing, revising, designing something to fit a particular audience. And then the 3D printing part of it, that's sort of the magic, and that's the part that is keeping the kids really interested in the possibility of combining science, technology, engineering, art, and math. It's pretty amazing.